Hello, this is the third video that I'm doing on Lewis structures. This time I'll be explaining how to do Lewis structures for covalent bonding within polyatomic ions. So the first thing I want to talk about is what a polyatomic ion is. Generally speaking, what it is it's a group of different atoms which together have a charge. So they kind of share a charge. On the back of the periodic table that I give you, there's a list of polyatomic ions. So you need to find that list so you kind of know what you're making here. But yeah, so that's how that works. So polyatomic ions, the way that you can identify them is that there are multiple things together, and they are going to be a bunch of different things. So what I'll do here is I'll go through each of these. I had left the answers up there from before, but just clearing those out and starting back from scratch. What we have here is, it says step 1 is to determine the total number of valence electrons which is brought by the atoms in the structure. So I'm going to do nitrite as an example. Nitrite, if you look it up on the back of your periodic table, you should see it's NO2 minus. All right, and so the first step it says determine the number of valence electrons. Well, what we've got here is we've got a nitrogen which has 5, and then we've got 2 oxygens, each of which have 6. All right, and so the total valence electrons brought in this case is going to be 5 plus 12, which is 17. The next thing you have to determine in the step, it says, is figure out how many electrons you would need to give everything the octets that it needs. I said, or duets in the case of hydrogen. So it's 8 times the number of non-hydrogens plus 2 times the number of hydrogens. There are no hydrogens in this structure, so everything wants 8. So for our octets, we say there are 3 atoms. There's a nitrogen and there are 2 oxygens, so there are 3 atoms. They all want 8. 3 times 8 equals 24. And then as the last step here, we calculate the number of bonds. The number of bonds is equal to the octet, which is 24, minus the valence, 17, plus the charge. I'm going through this equation this here, number needed for octet minus the valence plus the charge over 2 is the number of bonds. So octets was 24 minus the valence electrons, which was 17, plus the charge. This one has a charge of -1 over 2. What you should get there is 6 on the top over 2, which tells us that we have 3 bonds. Now what we can do, I'd say the first thing that comes normally goes in the center, so we've got the nitrogen, then I'll put a couple of oxygens out around it. We need to put in 3 bonds, so 2 just to get started. We have to make sure everything is bonded to the nitrogen, and then we're going to add in a 3rd bond there somewhere. I'll just put that 3rd bond there. And then what it says to do is fill in the remainder of the electrons that are needed to form octets on things. So if you look at the oxygen, it has 2 bonds to it already. It's double bonded to the nitrogen. Each bond contains 2 electrons, so the oxygen kind of already has 4 electrons through those bonds, which means that it needs 4 more. The nitrogen has 3 bonds on it, 2 electrons are in each bond. All right, so there are 3 bonds. Each one contains 2 electrons. So the nitrogen right now has 6. We're going to put 2 more on it. Then this oxygen here at the bottom, it's only got 1 bond, which means it has access to 2 electrons. It wants 6 more, so we'll put 3 pairs of electrons on it, and it looks like that. All right, and then you just throw a set of brackets around it and put the charge. All right, and that's that. It mentions here that you can, to double check yourself, count the number of electrons in the structure. And so what you can do is if you count all of the electrons and then count the bonds for 2, you can verify that it adds up to the number of valence electrons plus whatever comes from the charge. So if you count the number of electrons in this structure, counting bonds for 2, you should get that there are 18 electrons. 18 makes sense because we have 17 valence electrons that were brought, and then we got an extra electron because it has a -1 charge. And so there are 18 overall. All right, next going on to this nitrate ion. This is NO3 minus. That's nitrate. Again, you'll be looking at your list on the back of your periodic table to figure out what these are. For the valence electrons, we have 5 from the nitrogen plus 3 times 6, because there are 3 oxygens. What we get there then is 23. For the octets, they all want 8 because none of them are hydrogen. Hydrogen wants 2, but none of them are hydrogen, so they all want 8. There are 4 atoms there. There's a nitrogen, and there's 3 oxygens. So we say 4 times 8, and that gives us 32. Then to find the number of bonds, we do octets. That's 32 minus the valence, 23, plus the charge, plus -1 over 2. And from that, we end up with getting 4 bonds here. We've got a nitrogen with 3 oxygens around it. So oxygen there, oxygen there, oxygen here. All right, we've got 3 bonds right now, so we're going to add a 4th one on somewhere. It doesn't matter where. I just put it on this 1 oxygen there, but it has to go between one of the oxygens and the nitrogen. And so now we've got 4 total bonds. So again, we're going to count how many electrons each thing has access to and then give it whatever it needs to remain. So this top oxygen, it's near 1 bond, so the top oxygen gets 2 electrons from that bond, which means it needs 6 more to have an octet. All right, the nitrogen, if you look around it, it has 4 bonds. 2 electrons in each bond means that that nitrogen has access to 8 already, so the nitrogen is good. It doesn't need anything else. The oxygen on the right here has 2 bonds, which means it has access to 4 electrons from those 2 bonds, which means it needs 4 more electrons. And then the oxygen on the bottom, like the oxygen on the top, only has 1 bond on it, so it needs 6 additional electrons. All right, then you throw brackets around the structure and say the whole thing has a negative charge. All right, moving on to the actual examples here. Oops, got to clear these out too. So we'll start here with hypochlorite. Hypochlorite, if you look it up, has a formula of ClO minus. All right, so we'll do the valence. 7 from the chlorine, 6 from the oxygen. You should get 13. Then we'll do the octets. There are 2 here. Neither of them are hydrogen, so they both want 8. So 2 atoms times 8 equals 16. All right, and for the number of bonds then, we do 16 minus 13, octets minus the valence, plus the charge, so plus -1 over 2. And that tells us that we have just 1 bond in this case. Take the Cl and the O and connect them. Neither one is really central because there's only 2 here. All right, we put in our 1 bond. Then we put in the electrons we need to make 8 around each one. All right, put a bracket around it. It's got a -1 charge, and we're done with that one. For hydroxide, this is OH minus. For our valence, oxygen brings 6, hydrogen brings 1, so we've got a total of 7 there for the valence electrons. For the octets, this is the first one that's involved hydrogen, so the oxygen wants 8, but the hydrogen only wants 2, all right, because it wants to be like helium. So we end up with 10 there needed for our octets, or duets in the case of hydrogen. And then we take 10 minus 7 plus the charge plus -1 over 2. And we get 1 bond for this one as well. So it's O and H, single bonded. Hydrogen doesn't need any more electrons on it because it only needs 2, but this oxygen needs to have 6 more to bring it up to 8 because that 1 bond counts as 2. All right, and this is where we're at with this. And it ends up being a minus charge. Alrighty. For chlorite, chlorite is ClO2 minus. All right, same way, valence, 7 from the chlorine plus 2 times 6, because there's 6 for each oxygen, and there's 2 oxygens. You add those together, you get 19. For the octets, there are 3 things here that are not hydrogen, so we're going to say 3 times 8. That equals 24. Then we do 24 minus 19 plus the charge over 2. And you should get 2 bonds for that. We've got ClO2, so the first thing normally is in the center, so we'll put Cl in the center, an O on each side of it. Single bond, all right, and we've used our 2 bonds on this one, so now we just need to fill around to get octets. This oxygen needs 6 more because it has that 1 bond, which is worth 2. The chlorine has 2 bonds, which means it has access to 4 right now. It needs 4 more to get 8. And then this oxygen needs 6 as well because it gets 2 from the bond. All right, then brackets around it and minus charge. Moving on to bicarbonate. This one's a little bit weird. It's HCO3. This one's a big one, and it's got a charge of minus. All right, so for our valence, we've got 1 for the hydrogen plus 4 for the carbon plus 3 times 6 for the oxygens, which gives you 23. For our octets, we have 2 for the hydrogen plus, there are 4 non-hydrogens there. There's a carbon and 3 oxygens, so 4 times 8. All right, and you find there that they would want 34. Then you do octets minus the valence plus the charge over 2. And on this one you get that there are 5 bonds needed. So how this works out, normally the first thing is in the center, but hydrogen is never in the center. It only ever makes 1 bond. So hydrogen's off to the side. We're going to have here, actually it's going to be connected to an oxygen, which is attached to a carbon, which is attached to the other oxygens. So you might recognize this as being something that happened with like the alcohol groups where it's O and then H. That's a pretty common thing where you've got an O and then H coming off. So right now I only have 4 bonds. I need to add 1 other one in there. So I'm going to add a 5th bond there. Then I just go around and make sure that everything has the electrons that it needs to have octets. All right, so that's done. Throw some brackets around it. It's got a charge of -1, and that one is done. For carbonate, this is CO3. Oops. CO3 2 minus. So for this one, for our valence, we've got 4 for the carbon plus 3 times 6 for the oxygens. You add that up, you should get 22. For our octets, there are 4 atoms here. None of them are hydrogen, so they all want 8. You get 32 for that. To figure out how many bonds, we say 32 minus 22 plus the charge. In this case, it's -2 now. All right, over 2. And that gives us, for a number of bonds, it gives us 4 bonds. So then we have carbon in the middle, 3 oxygens around it. All right, one of these needs an extra set of bonds, so I'll just throw it on this one here. So there's a double bond there, and we've got 4 bonds total. Fill in the extra electrons that we would need. All right, carbon is good because it's got its 4 bonds, so it's already got the octet. Set of brackets around there. 2 minus on this one because it's got a 2 minus charge, and that one is done. All right, sulfate is SO4 2 minus, SO4 2 minus. So for our valence, sulfur and oxygen both have 6 valence electrons. So there are 5 atoms. Each of them has 6 valence electrons. All right, and that gives us 30. Then for octets, there are also 5 atoms, none of them hydrogen, so they all want 8 for their octets. And that tells us that we would need 40. So then we do 40 minus 30 plus the charge, which is negative 2, over 2. We end up on this one getting 4 bonds. So we put the sulfur in the middle, 4 oxygens around it, single bonds to each of those. Right, then they need electrons around them to fill in. All right, and then you just throw the brackets around, and it is a 2 minus charge on this one. All right, getting close to the end here. Ammonium is NH4 plus. All right, so for our valence, we've got 5 for the nitrogen, plus 4 times 1 valence electron for the 4 hydrogens. You add that up, you should get 9. Then for our octets, nitrogen wants 8, but each of those hydrogens only wants 2. So you calculate that, you should get 16. Then you do 16 minus 9 plus, in this case the charge is positive 1, so it's plus 1 over 2. You get 4 bonds needed. All right, so we'll put the nitrogen in the middle. 4 hydrogens coming off of that. That actually gives us our 4 bonds. The nitrogen is good because it has 8 electrons around it with its 4 bonds. The hydrogens are good because they only need 2 electrons. So we just throw brackets here. This is a plus 1 charge. All right, and for the last one here, PO4, 3 minus. For our valence electrons, P has 5 oxygens, so plus 4 times, each oxygen has 6. Add those together, you should get 29. Then the octets, we've got 5 atoms here. None of them are hydrogen, so they each want 8. You multiply those, you get 40. Okay, then we have 40 minus 29 plus the charge plus negative 3 over 2. And what you get from this is 4 bonds. So we've got a P in the middle, 4 oxygens around it. Fill in the electrons where needed, so we need 6 on each of these oxygens. All right, throw brackets around it. Put the charge on there, and we are done. So it's a pretty repetitive process, but hopefully through doing that, you got pretty good at doing these sorts of ones. The indicator that it's going to be a polyatomic ion is you're going to have multiple nonmetals usually shown there, and there'll be a charge on it, and so you'll know you need to do this process for finding the Lewis structure of polyatomic ions.